What is Internet? Internet is a set of physical components, a network architecture, and a communication service. The physical components are in terms of hosts and terminals, router nodes, switches, access points, and links that are all connected together in a hierarchical architecture, such as the mobile network that is connected to the national and international internet service provider, the domestic network that we all have at our home, that is then connected to the regional internet service provider, and also the campus networks. The end hosts are capable of sending and receiving information for their applications. Depending on the type of end host, they may have different characteristics, such as personal equipment are different from servers, and all of them are different from smart devices that are not just sending and receiving information, but they are also generating information, such as in the case of Internet of Things. All these components, all these end hosts are connected through physical media that we call internet links. They differ on their physical nature, such as optical fiber, coaxial cable, radio, and they support different transmission technologies, and they are different in terms of speed of transmission, such as bit per second or terabit per second, etc. For instance, in the wireless transmission world, the transfer quality through radio channels depends on channel range in the frequency spectrum, signal interference and reflections, obstacles along the propagation path. And we can have different channel types, such as Wi-Fi and cellular, terrestrial microwave, satellites. In the case of satellites, for instance, the delay depended on the satellite type. For instance, we can reach 250 milliseconds for the geostationary satellite type. However, in this slide, we can see we can have a clue on what is the main difference between the two media, the wireless and the physical one. The first difference is in terms of the frequency bands they use to send and receive the data, but also the speed is different. In the radio channels, as in vacuum, we can have a speed of 3 multiplied by 10 to the power 8 meter per second. Instead, for the wireless channels, we can reach the 2 multiplied by 10 to the power 8 meter per second. This because of an attenuation that is given by the wired media. However, all these main components, such as the end host and the network nodes, such as the routers, they can operate on a packet of information. However, also other components that operate at different levels of the network, such as access point and switches, they instead handle a different type of information. And this will be clear in a later stage of this MOOC series, when we will investigate the network layer and the link layer. The terminal equipment, such as hosts, servers, and smart objects, they access to the networks through the access networks. They can be home networks, mobile radio networks, corporate networks. All of them use communication resources, for instance, switching equipment, transmission systems, and also transmission media in terms of wired and wireless links. However, all these access networks can be made by different technologies, such as DSL, CATV, optical fibers, and in terms of wireless networks, such as data networks and mobile radio networks, and corporate networks can be done by specific technologies that are provided by internet service provider. Let's make an example of the DSL. So in the wired access world, we have the digital subscriber line that exploit the telephone line to send and receive data. So voice and data are sent on different frequencies over a dedicated line to the central office. Then the data is routed over the data network, and the voice instead is routed over the voice network. A specific example of the DSL is the ADSL, the asymmetric DSL, that have different data rates in the upstream and the downstream. For instance, 1.5 megabit per second in the upstream and 16 megabit per second in the downstream. Another example is the optical fiber. With the optical fiber, we increase the performance of the access network, and depending on the penetration of the optical fiber towards the final client, this can be divided in further technologies, such as the fiber to the exchange. It is the fiber that reaches the central office, and then towards the client we have the copper, for instance. Or the fiber to the cabinet, the fiber reaches the cabinet, and then from the cabinet to the final client we have the copper. Instead, the other two are technologies where the optical fiber are more closer to the final user, such as the fiber to the building, it reaches the main building. And then the fiber to the home is when the fiber reaches the final home of the user. Instead, for the wireless access, we can have data networks that make possible the access to the internet through the access points. And this can be divided in different technologies, such as Bluetooth for the short-range networks, at most 1 meter coverage. Wi-Fi networks can reach at most 100 meter coverage, and the WiMAX extend this coverage until 10,000 meter coverage. On the other side, we have the mobile radio networks. Instead, it is another access network technology that is made by base stations. These rely on various generations of mobile radio networks, such as the 2G, 3G, 4G, 5G, and in the future we will have the 6G. And here the coverage of distances is in order of kilometers, thanks to the cellular networking. However, the fundamental architectural aspect of Internet is that Internet is a puzzle of many interconnected networks. And this has two major implications. First, the Internet technology can interconnect heterogeneous subnetworks, so it can interconnect different network technologies among each other. And then the Internet is composed of many networks managed by independent operators or Internet service providers who set up mutual agreements between each other. The ISPs are specialized on specific network segments. We can identify the tier 3 local ISPs that interface the end users. Then we have the tier 2 as regional internet service providers that provides connectivity to local ISPs. And then we have the tier 1 that are the national and international ISPs who manage continental and intercontinental wide area networks, forming the internet backbone. And then we have the internet exchange point that are specific points that interconnects all the tiered networks. However, we can further divide the internet architecture based on the coverage that it can reach. We have the local area networks that mainly covers the building networks or the campus network or domestic networks, for instance. Then we have the metropolitan area networks that cover cities in the nation. And then we have the wide area networks that instead extend over nations and can interconnect countries. However, Internet is also a communication service. The communication service is based on communication protocols, and communication protocols are a set of rules to format, send, and receive information. So at the end, what is Internet? There are many definitions of Internet, but we can try to give one definition. One possible definition is that the Internet is a communication infrastructure enabling communication services that support a set of different distributed applications, such as email, e-commerce, file transfer.